Hello and welcome back. Today we are thinking about erosional landscapes in the UK. So by the end of this session you are going to be able to explain the formation of erosion features, describe what processes have caused these features, and explain how glaciers have shaped our landscape. So as always, this is the specification. We are looking at this today, so the characteristics and formation of landforms resulting from erosion. So corries, arêtes, pyramidal peaks, truncated spurs, glacial troughs, ribbon lakes and hanging valleys. So we've got a lot to get through. So I would like you to copy out this table into your books or on your sheet, whatever you are using, and as we go through I would like you to fill it in. So you need to have the features, some space for a sketch, the formation and a process that has formed these landforms. So what is a U-shaped valley? This is our first one. The glaciers basically change a V-shaped valley that we'll see with rivers into a U-shaped valley by creating a steep-sided, wide valley in the shape of the letter U. They are formed by a glacier that moves down the valley because of gravity. Instead of it going like this, the base of a glacier isn't that thin, so it erodes it and it carries all that sediment away and becomes a U-shaped valley. As the glacier moves down the valley, it plucks rock from underneath, so we thought about plucking and abrasion last time. It plucks rock from underneath and rubs against the valley, eroding it further. So we've got our plucking and we've got abrasion. This deepens, so down, and widens and to the side of the valley. Glaciers cut U-shaped valleys with a flat floor, steep sides through erosional processes of plucking and abrasion. So this is your first landform. Pause the video and fill in your table. Secondly, we have corries. Snowflakes in a shaded north-facing hollow. As more snow falls, the snow is compressed and the air is squeezed out to become ice, or firn, and then ice. With the pressure of more layers of snow, the compressed snow will, over thousands of years, become glacial ice. Erosion and weathering by abrasion and plucking and freeze-thaw action will eventually make this hollow bigger. It over-deepens through abrasion. Freeze-thaw gets the sediment in there. Plucking takes it over that lip. Rotational slip is happening there as well. Even though the ice is trapped in a hollow and unable to move downhill, gravity will still encourage it to move through the process of rotational slip. These processes create a characteristic rounded armchair-shaped hollow with a steep back wall. When a corrie ice melts, the circular lake is often left behind, forming at the bottom of the hollow. This is known as a tarn. So here is some more diagrams of a corrie for you, step by step. So when the snow compacts into ice, when the ice is thick enough, it becomes a glacier. Through plucking and abrasion, the hollow gets deeper and the walls get steeper. Freeze-thaw weathering helps to bring that sediment, which can be used as a process and an agent of this abrasion. The rotational slip continues to happen and it goes over the lip of the glacier, over the lip of the corrie. The process of movement is rotational slip, so it's literally rotating and moving over. And then when it melts, it leaves behind a corrie lake called a tarn. So this is an arête. We've done it in this particular order for a very particular reason. An arête is a very sharp, steep-sided ridge formed when two corrie glaciers form back to back and grind each other away until it's sharpened until almost a knife edge. An arête is a knife edge ridge. It formed when two neighbouring corries run back to back. Each glacier erodes either side of the ridge, and the ridge becomes steeper and steeper and narrower and narrower. So the picture that you can see on the left here is Striding Edge, found in the Lake District in the UK, which gives us evidence that the Lake District was formed and altered by glacial processes. Striding Edge is an example of a frost-shattered, knife-edged ridge called an arête, which was created when two corries formed back to back. So this is a really helpful diagram that you can draw into your sketching section for your arête. Following on from that is what we call a pyramidal peak. Again, this is formed very, very similarly from an arête as a result of a corrie. So pyramidal peaks are formed when 3 or more corries are cut backwards into the same mountain and form a sharp point or peak at the top of a mountain, such as Mount Everest. When 2 corries occur back to back, they can form what we call an arête. When 3 or more, we end up with a pyramidal peak. So it's literally a peak at the top of a pyramid. Our next landform is what we call a truncated spur. If you remember, with rivers, we have our interlocking spurs where the water flows in and out. Essentially, a glacier has just gone and cut all that off and it's left it behind. What is left behind is what we call a truncated spur. So they're spread out like this, a little bit like that, and separated. So this is a blunt-ended sloping ridge which descends from the sides to the bottom of the valley. It's abruptly terminated due to the process of erosion through the glacier. That's abrasion going on there at the side and at the bottom. Glaciers tend to follow the straightest course and they have a lot more energy than rivers because of the compact nature of the ice. So truncated spurs are not interlocking spurs anymore, they're cut off and they're truncated, so they're left behind. They are rounded areas of land which have been cut off. They are often rounded at the top and steep at the bottom, and they are formed when glaciers move through the main valley and cut off the interlocking spurs. Similarly, we often have things called hanging valleys left behind. So you can see here, this is a truncated spur, and in the middle here, where a tributary river would have flown normally, that has since been cut off as well. The river continues to flow though, so it leaves behind a hanging valley. This can be seen along the main sides of the U-shaped valley that's left behind. A waterfall can often be seen there, but during glaciation, so when this was all still made of ice, a smaller valley glacier could also be found there. Within glacial valleys, there are many glaciers and small tributary glaciers, just like with rivers. The main glaciers erode the valley to as great extent as they want, so they are wider, deeper and have more mass and moraine as extensive tools of erosion, whereas rivers don't really have that. The tributary glaciers, so the smaller ones that join from the side, have less mass and moraine, so their valley is eroded less. This means that the main valley is deeper, wider, steeper, and it becomes really evident after the glaciers have melted. So what we see in the UK, in the Scottish Highlands, in the Lake District, and in Snowdonia. When a tributary glacier is left hanging above the main valley, when rivers return, they often form waterfalls in these hanging valleys. And finally, our ribbon lakes. This is a picture and an OS map of Buttermere in the Lake District. These are formed because of different kinds of rock. So you might remember with rivers there are various different types of rock and different landforms happen as a result of different softness and hardness of rock. Same with ribbon lakes. So ribbon lakes are formed because glaciers erode soft rock easier than hard rock. So here are 3 diagrams for you that might be helpful. So before glaciation happens, we have our hard rock and we have bands of soft rock just naturally. Then when our glacier moves over these bands of hard and soft rock, the soft rock gets eroded more quickly, just as with rivers, just as with coasts. Then when the glacier melts or retreats, we have this hollow that is left behind that then gets filled up by the water table and rain and things like that, and leaves behind a ribbon lake. So, a ribbon lake is a large, narrow lake occupying a U-shaped valley, so the ones that glaciers have eroded through. It forms in a hollow when a glacier has more deeply eroded a less resistant rock. Or it might fill up a valley behind a wall of a moraine, which we'll talk about later, across the valley. This is just like a barrier. These are long, thin lakes that collect from glacial meltwater and rain after the glacier has melted. During glaciation, the glacier erodes some parts of the valley floor more than others. This is often due to the strength of the bedrock, because there is thicker ice in one region, or because there's thicker ice in one region than another. When a glacier melts, it fills these depressions or holes where the valley floor was eroded most. These lakes can also form because meltwater from receding, so glaciers that are retreating, is trapped behind a moraine, which is essentially a barrier or a dam caused by the glacier moving sediment forward. So for the last couple of minutes, I have 2 questions that I would like you to try and attempt. Firstly, can you explain the formation of a glacial trough or a U-shaped valley? And then your second question, can you explain the formation of a corrie? So pause the video, spend about 6 minutes on each, and then I will go through some example answers for you. So, explain the formation of a glacial trough. To get 4 marks in an exam question, you need 2 developed points. So, you might be able to see it here. Ice begins to occupy a former river valley. It is much deeper than the river and fills much of it. Ice erodes the interlocking spurs by abrasion and plucking, so there's a really good detail there. They've talked about the processes that are going on and what it was like before as well. The ice freezes to the rock and pulls away pieces of rock as it moves. It then uses this material in the abrasion process. So it's linked to this plucking and the material that's come from that and abrasion. This gives a very steep-sided valley where the spurs, so our interlocking spurs of rivers, have been truncated and the valley is much wider and deeper. So that is a perfect full mark answer. It would give you 4 out of 4 for explaining the formation of that glacial trough. And then your second question, explain the formation of a corrie. Step 1. Snow collects on a hollow on a mountain and over years it becomes ice. 1 mark. Above the ice, freeze-thaw weathering weakens the rock and breaks bits off. As it moves, bits of rock are attached to it and are worn away. Point 2. Plucking and the weathering means there is a lot of rock in the ice. The ice uses this to erode the bottom of the hollow. If you wanted to add even more detail, you could say through the process of abrasion. And then finally, point 4, the rotational slip movement of the ice results in the armchair shape with the lip at the end. So that explains the formation of a corrie in 4 marks. So I do hope this has been useful. I will see you next time for processes and landforms of glacial deposition instead. See you later.